we were talking about graphing these quadratics. This is not the slide I want to be on. Sorry. This is the slide. And when we graphed them, we found the axis of symmetry. How did we find the axis of symmetry? What was the formula? And vertex was an ordered pair. The x was the number we got from our axis of symmetry. And then how did we get y? Yes, put x back into the equation. So yesterday we were finding those two pieces of information and then drawing a rough sketch. Today we are going to draw a more accurate sketch. Okay, and I'm going to show you guys some tools to help you get the best graph that you can on these. So let's go through the first one. Y equals x squared. So if I asked you to find the axis of symmetry, we know it's x equals the opposite of b over 2a. What is my a in this problem? It's the number in front of x squared. B is the number in front of x, so that's just 0. What's our c?
0.
So if I do the opposite of b, so opposite of 0 is still 0, over 2 times 1, we get
0.
So the axis of symmetry is x equals 0. The vertex is an ordered pair. X is 0.
Y is 0.
And if you put 0 in, 0 squared is 0. All right. Let's talk about graphing that. 0, 0 is a point on my graph. Can you tell me if this will open up or down? Because it's positive x squared. We know the axis of symmetry is x equals 0, so it's right here. But let's say I need a more accurate graph than just a single point. We can make a t-chart. We did this back when we first started graphing lines. So my vertex, all the t-charts that I've given you today have 5 spots. I'm going to put the vertex in the middle because the vertex is the middle of my graph. And then I need some points on either side. So if x is 0, then things bigger than that, I could put in a 1 and a 2. If I wanted to go smaller, what could I do? All right. And then how do you think we get the y's for all of these? Okay. So negative 2 squared,
4.
negative 1 squared, 1 squared, and 2 squared. All right, so we can plot all of these points. So negative 2, 1, 2, 3, 4, negative 1, positive 1, we have 0, 0, 1, 1, and 2, 4. So now I have a pretty accurate graph. All right, does everyone understand where all these numbers in my table came from?
Nope.
Okay, do you know how I got my x's?
No.
Then
I'm confused on where you plug in the number at to get the y.
this equation right here.
Okay, so you just make negative 2. Okay.
Anything else? All right, if I ask you for domain and range. Domain, we did these with lines and things. Domain is like your x values. Okay, if I go from left to right, keep in mind, as this parabola goes, it's going to keep extending both directions. So what x's will we end up hitting? All of them, right? So it's all real numbers. And that is always the case. The graph is always a parabola. It gets wider and wider with time. We can plug in any number for x that we want. When I look at my y's, when we talked about range, that was a y. And I said, okay, think about going from the bottom up. So if I'm starting down here, what's the first y value we hit? 0. And then we hit everything above that. So we would say y is greater than or equal to, because we can't hit 0. All right. Now I want to show you guys something. On your graphing calculator. Okay, so everybody follow along with me. If you want to graph something, you go to the y equals. If you have something in here, just push clear, and it goes away. If I put in my original function, it was x squared. Okay, if you push graph, does everyone have a graph that looks like this? If not, I might need to change some settings on the calculator. Does that look like the graph we drew? Yes. Okay, here is another really cool feature on these calculators. You notice above this graphing button it says table. If you push second, and then the graph, that takes us into our table. Look at these points. You can go up or down, but aren't these points we use? -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So you can get your points from here as well. Okay, you don't necessarily have to take all the time to plug them in yourself. If you have this resource, you can use it. Did everybody get something that looks like this and know how I got to that? If not, raise your hand so I can help you right now. Okay, if you hit second. All right. You have to at least write them down. So if you use this, that's fine, but write down the points on my XY chart so I know what points you were looking at. All right, let's look at the next one. So we do have to find the axis of symmetry by hand because otherwise that table, you can scroll up and down forever. It's going to keep giving you values. We don't just want to plot 25 random points. We need to find the vertex so we know where the middle of our graph is. So we have to do that part by hand using our formula. So x equals the opposite of b. What is my b value? So my a is 1, my b is 2. So the opposite of b would be a -2 over 2 times a. So we get -2 over 2, which is, so my axis of symmetry is x equals -1. Now technically, could I use the calculator for the rest?
Yep.
Yeah. Put your -1 in the middle of your table so that you can make sure you're picking points on both sides. Okay, so if I wanted points smaller, I might go -2, -3. If I want points bigger, 0 and 1. So we need to go back into our y equals, clear what's there, and type in our function. X squared plus 2x minus 1. All right, we can look at the graph first. I'm going to go ahead and just look at the table so I can get my points. To get to the table, so you notice on your calculator, table is in blue, so you have to push the blue second button first. And then graph takes me into my table. Now, make sure you're picking the points we need. So, if I'm looking, the x's, when my x was -3, y is 2. When x is -2, y is -1. -1, -2, 0, -1, and 1, 2. Do I have to have the calculator to get these? No, you can get them by plugging in, just like we did yesterday. This is just kind of a tool you can use. So what is the vertex from here? It's that ordered pair, -1, -2. All right, so if I graph this, -1 means go left 1, down 2. Okay, we have -2, -1, -3, 2. I would like for you to draw in your axis of symmetry just so we can kind of check. You know, that goes right through the middle. It's like a dashed line. Is it the same on both sides of that line? Yeah, that's your check. Kind of make sure you did it correctly. If you also wanted to check your graph, what else could you do? Yeah, look at the graph on your calculator. If you just hit this graph button, we can see. Does that look about like ours? Yes, but we need the table to get the exact points on our graph. Are there any questions on how I got my points or plotted them on my graph? Yes.
So, on this, because when I do this side, I go, it's 0.
What's the domain of this? All real numbers, every time. What is my range?
Equal to greater than negative.
Greater than or equal to negative 2. Notice that negative 2, that was the y value of my vertex, wasn't it? That's my lowest point. Other questions? All right, let's look at, I'm going to jump around here. Let's go to number 4. All right, so what is my A? And my B? 4. C is 1. So axis of symmetry, x equals, what is the opposite of B?
-4.
That was the opposite of A.
Oh.
Opposite of B over 2 times A. So we get -4 over -4, which is
Oh.
So axis of symmetry, x equals 1. So now my vertex, we know the x value is 1. What's the fastest way to get your y? The calculator. We know on our table we're going to put 1 in the middle. Then we need points bigger and smaller. But we can get all those y values from our calculator if we want to do them at once. So you go to your y equals, clear what's there. You need -2x squared plus 4x plus 1. And I'm going to go into my table first. So you can move up or down for whatever points you need. So if I look at this first point I have on my table is -1, and that tells me y is -5. When x is 0, we get 1. X is 1, we get 3. 2, 1, and 3, -5. So what is my vertex? 1, 3, good. Alright, so now I plot these. -1, 5 means left 1, down 1, 2, 3, 4, 5. 0, 1, 1, 3, 2, 1, 3, -5. How does this parabola open? Down. And how would I have known that before I ever graphed it? Had a -a. Okay, so we can draw this in. If we did the axis of symmetry, that's just the vertical line going through the vertex, and we can check our points should be the same on both sides of it to just make sure we didn't make any mistakes. Domain on every single problem. All real numbers. My range though, this time is different. If I look at this, I'm hitting all the values below my vertex. So my range would be y is less than or equal to 3. Alright, how are we doing with these? Good? How about one final problem together, and then you guys can do them on your own? I'm going to jump to, how about number 10? I think it's on the next sheet of paper. Alright, what is my A? What is my B? C? So vertex, opposite of B, the opposite of negative 18 would be over 2 times negative 3. So you get 18 divided by negative 6, which is negative 3. So axis of symmetry is x equals negative 3. And I know negative 3 is the x in my vertex, so that's the middle of my table. What are my numbers smaller than negative 3? Negative 4, negative 5. Bigger would be negative 2, negative 1. So we can go to our y equals, put in our equation. Negative 3x squared minus 18x minus 20. If I go into my table, and we might have to go up or down to see the x's that we need. The first one I want is negative 5. So then we put in our points. We have negative 5, negative 5, negative 4, 4, negative 3, 7, negative 2, 4, and negative 1, negative 1. Alright, is everybody getting that? And then you guys remember how to plot these. So if we go left 5, down 5. Left 4, up 4. Left 3, up 7. Is this one opening up or down? And we should have known that at the beginning because my A was negative. Kind of missed my points there. Axis of symmetry we know is just that vertical line going straight through the middle. To check that's the same on both sides. And when in doubt, just take a second and look at the graph on our calculator. Does that look like what we graphed? Yeah, so that's how we know we're on the right track. Final questions. So, I haven't filled in yet. What's the y value for my vertex? X is negative 3, y is 7. What's our domain? And what's our range?
7.
Less than or equal to 7. So if it opens up, it's greater than. If it opens down, it's less than. All right, do we need more of these?
No.
Okay.